This video. So Rizia and Ariana live in houses that are next to each other. Rizia lives in a two-story house while Ariana lives in a one-story house. They throw a tennis ball at each other through their open windows. The path of the one particular, what happened there? Throw, that's a typo, right? From Rizia to Ariana is modeled by, and there's that equation. That is like that giveaway. Type that into your y1. So I'm going to go ahead and do that right off the bat. Let's type that into our y1. I'll clear everything else. Negative 7x squared plus 10x plus 18. A couple of observations. I know this is pointing down. I know that it's somewhat of a narrower curve, right? I know that my y-intercept is higher up, right, on the 18 mark. So, right, you're making observations. It's in general form. I don't know the vertex, but I do know the y-intercept. Oh, there it is. So I'm going to go zoom 6 so we all see the same thing. And I'm going to adjust accordingly. Notice that because I'm not interested in the negatives, because it says f of x is the height of the ball in feet and x is the time in seconds. So I'm not interested in the negative x values. So I'm going to go window, and the x min I'm going to go maybe minus like -2 or something like that. Same with my y min. I'm not interested. It's above ground, right? So I'm not interested. I'm only going to go -2 there as well for the y min, but the y max I do need to increase. So I'm going to go watch this. I know that my y-intercept is 18, and it's going to go up a little bit and then down. How do I know that, Mr. Jason? How do you know it's going to go up? Remember, there was the one slide in your notes. If b is not equal to 0, the vertex is not going to be on the y-axis. It's actually going to go up and down. So I'm going to go 30 with the y max. I have no idea. It might backfire. Hey, that actually looks pretty good. So if you're seeing something like this, you're doing okay. All right. Now let's start answering. So I'm going to just make sure I tell myself that x is time. And what is it? What units? Let's do that as well. It's in seconds. And the y value is representing the height. And that height is in feet, not yards, not meters, right? So I know that the x and the y values are associated now with time and height. Okay, so every single point on this parabola tells me the time and the height at that particular time. Okay, so moving along. How long does it take for Ariana to catch the ball? And I need to make highlight a certain aspect here because it says Ariana catches the ball 5 feet above ground. You notice that? That little sliver there? So this thing is not, if you want to graph it, right? Yes, our calculator is showing us everything, but really, if you're just focusing on this story, this is what happens, right? There's a catch there, no pun intended, right? That's a catch here. You got to watch out for that. So the story ends here. Okay, so keep that in mind. So for A, let me do that here. How long does it take? Right, well, it would be from the throw to where it's being caught, right? So I know that this is 0.18. How do you know that, Mr. Dirksen? Right, it's in general form, so the 18 represents the y-intercept, which is the initial, it gives me the initial height of 18 at time 0. I hope you understand that. And what would this point be right here? Which coordinate, out of that coordinate, I know that the height is 5, correct? It's being caught at 5 feet above ground. So this is done here. You want to go arrow here? That 5 is right there. So what is it that I need to find in this case? The time, right? The time. How do I find the time? What do I need to type into my calculator? Remember, when you are given a y value, you type that into your y2. If you have any indication of what the y value is, it goes in there. And then we're going to go second, trace 5. That's intersect, right? That's intersect. You're finding the intersection between those two. So let's go ahead and do that. So notice what I did. I typed this in. I adjusted my window, and then I start answering. Okay, so y2 is equal to 5. There it is. I don't care about this one out here, because I know this story, time starts at 0. And then it stops here when it's being caught. So I'm going to go second trace 5. I don't see my cursor, so I'm just going to look at these values here. If I go to the right, I'm going further down into the negative, so wrong way to go. Go left, and it's coming up. There it is. It's close enough. Enter, enter, enter. So that is x is equal to 2.5, no, sorry, 2.25, my bad. And that is seconds. Right? How long does it take? It takes, right? You can just make a little sentence. It takes 2.25 seconds. Now, do you need to give a diagram, all of this? No. If you understand what's happening, you just need to do this part, solve for the x value, and then tell me that that's the answer. Does that make sense? On a Monday morning? Yikes, right? All right, B. What's the initial height of the tennis ball, right? Initial height given by y-intercept. That's where we would find that, right? You could use your calculator to find this, but I just use the equation because it's 0c, right? Remember, 0c is the y-intercept. It's just a little aside. So 18 feet above ground. So don't just say it's 0, comma 18. That's the coordinates of the right? At time 0, it's 18 feet. So you just got to be very clear that you're referring to that 18 that's answering the question. That was the initial height of the ball. Okay. What's the maximum height? Where would you find that? Find vertex, right? That's you. Find the vertex. So we type second, trace. In this case, it's a max, right? So we're going to go max. So I'm going to, you might ask, I don't know if you ever wonder, what happened to this equals to 5? Can I just leave it there? Yes, you can. You can just leave it there. Second trace, max, right? You go to the left of the vertex because it's asking for left boundary, enter, go over it, right, enter, enter. And that is 0.71, 21.57. That would be the coordinates of the vertex. But you need to find the maximum height, right? The maximum height is this second number. Max height is 2157. We are in feet, right? So give me the coordinates and then tell me which one of those two numbers is actually answering the question. The way I roll, okay? Next, D. How high is the ball after 2 seconds, right? They're giving you the time, right? So we're going to go second, trace, value, right? That's the first option, by the way. And we're just going to type in x is equal to 2 seconds. So let's go ahead and do that. Second trace value. The time of 2 seconds is what we're interested in. And it tells us that y is equal to 10 feet. That's a round number, right? No big deal. So ball is 10 feet above ground. or you can say is at a height of 2 feet. I'm fine with that. E, state the domain and range of the scenario. I'm glad you asked, right? So the domain is what? In this case, we're talking time, right? Time starts at 0, and it is caught where? That's why I like to make little sketches as I'm working through it, because then you know that this is where it ends. And that was 2.25 seconds. Okay, so that's where I put in here, 2.25 seconds. And my range is the heights that are allowed. What's the lowest height that we ever get to in this scenario? 5, right? 5. We don't hit the ground. So 5 is the lowest ever, and the highest ever is given to us by the vertex here. So that's 21.57. Done. You're done domain and range. Right? I know there's always some set notation fans in the classroom. That's okay. Right? If you want to do it that way, in this case, you have to use x, right? And the other one is f of x. So it's 5 f of x less than equal to 21.57. Okay, so you have both side by side. F, state the equation that would model the path of a throw that results in a greater maximum height. I did this on Thursday. Can I just say, I don't think there's a copy paste option here, but if you ever find it, please let me know. I'm just going to copy that exact equation. But remember that C value, you know what it actually, it's a y-intercept, all right, it is. But raising that value actually raises the whole equation. Like raising that C value, it's like you're lifting everything, not just the y-intercept, you're actually raising the whole thing. If you're bringing this C value down, you're lowering the whole thing. So I would just go with something like that, plus 20, right? Because you can clearly tell that it will have a maximum, a greater maximum height. Okay, so what I will do here is changing or I will say increasing, no, I think it's better to say changing the value of C, right, alters the height, I will say, height of the parabola. Therefore, right, y is equal to negative 7x squared plus 10x plus, let's say, 25, right? Will result in a greater max height. You don't have to do this part. Let me just, I will actually type in plus 25 here, graph it, and I will find the vertex of that red line. So I'm going to jump to the red. See, I went, when I go up, I jump to the red line. And, oh, it's going way down there. So I got to go left boundary. Let me just, here it is. I got to go to the left of it and to the right of it. How much taller is it? You see that? You can probably not see it. It's 28.57. Do you see that? Earlier it was 21.57. And it went up by 7 units. And if you notice our y, like earlier was plus 18, now it's plus 25, it actually went up by 7 units. So if you increase this, right, by 7, so will every other point in that parabola. So the vertex will be higher by 7 units, right? The best part, I love the graphing part. I hope you do too. Not, right? But there's the, right, make sure you have arrowheads on the, you don't want them on the going negatives, okay? We don't want them there, but we do want them to the positives. And pick up a good scale. This action along the x-axis ends at 2.25. So if this is 1, so 0.5, 1, 1.5, 2, that actually works pretty good. I don't know what I did on the key, and really it doesn't matter as long as you're consistent, right? So this is 2.5 here. And remember, this is time in seconds. You have to give me both. This is height in feet, okay? You have that. And now for the y-axis, I'm just going to focus on the vertex. And so the highest point I ever get to is 21.57. So let me try 5, 10, 15, 20. That works pretty good. So 5, 10, 15, 20. So this must be 25. And make sure if you go up by 4 boxes, right, make sure that it stays consistent like that. Plot our points. 0, 18 is right about there. And the vertex is at 0.71, so this would be 0.75. So I'm just going to be shy of that and go up to 21. Right about there. That's my vertex, and then 2.25 is right about there, between 2 and 2.5. So certain points you can find the exact location, right? And then you just go cross it like that, and notice, don't go straight down to it, right? Like parabola sideways a little bit and then curve down. Don't forget your equation. Anything missing? I think I got it all. Labeled, intercepts, vertex, equation. Am I off or what? What is the part that confuses you? This? Oh, yeah. You were right to be confused. Yeah. Very important, actually. Very important. So on a Monday, you have to pay extra close attention to what I'm doing. I like it when I get corrected. I actually do, because that means you're paying attention. Yes. It doesn't hit the ground, does it? This is the 2.25. The 2.25 is here, right, at a height of 5. So let me adjust this, okay? Yep, thank you. There we go. Didn't affect much, but the graph would have been wrong, right? Like it didn't affect my scale or anything, but good catch, good catch. Yeah, perfect. So right there lies your range, and there's your domain. I hope my key stopped above ground, right? I hope it did. Yeah, I got some nods. Okay, you did the homework. Way to go. That's that.